Okay, solving a system of equations by graphing is the first method we're going to talk about. All a system of equations is basically the equation of two lines, so two linear equations. It could be in standard form, could be in slope-intercept form, or y equals mx plus b. When you graph those two lines, there's some options what happen. And in the most typical case is what you see here in this graph. The two lines intersect at a point. Now remember that the line, the graph, represents all the possible solutions for the equation that you have. So if I'm trying to find the solution to the system, it is the common solution, and the common solution is found at the point of intersection. So in this particular example, it intersects over here at -4 and down -2. So the solution to this system is the intersection of the two lines, which is the point -4 and -2. When we graph two lines, there's three possibilities what could happen. The first one is exactly what we just looked at a moment ago, is the two lines could intersect at a point. The intersection represents the solution. So in this case, the solution is the ordered pair of x is at 2 and y, we are up here at +4. Another possibility, two lines get graphed, they might be parallel to each other. Well, if lines are parallel and the solution is where they have a solution in common, which would be an intersection, there's no intersection here. So since there's no intersection, in this case, there would be no solution to this system. And our third option would be to have an infinite number of solutions, where when you graph the two lines, you graph one and the second one ends up being the exact same line again. And as we said earlier, the points on the line are solutions. So this point's a solution, that point there, and that point there, and there, and there, and all the way up along that line. Every point on the line, on and on forever, represents solutions. So in this case, there is an infinite number of solutions, or their intersection is every single point on the line. So as we take a look at some actual graphs now, a system of equations would look something like this, both of them in slope-intercept form. So I use the slope of 5 and the y-intercept of 1/2 to graph this purple line. And I start up here at 5 on the y-axis. I rise 1, run 2, put a point. Accuracy is very important, so I'm going to continue to do the slope many, many times, going down 1 and over 2, so I know the exact spots where that line touches the grid. My next line, I'm going to start here at -2 on the y-axis, and then from there I go down 3 and over 1. Well, going down 3 and over 1 is going away from the other line, and I want to find where they intersect, so I'm going to go the other way, up 3 and over 1, until I find the exact spot where they touch. That intersection is the solution. So the answer to this guy here would be x is -2, and the y value is up here at 4. Oh my goodness, instant replay of that last example. We start at 5, we rise 1, run 2, start at -2, go down 3 over 1, and yes, score! -2, 4 is the solution. All right, here we go. The next example. Once again, they're in slope-intercept form. So the first one, we start here at -5 this time, rising 2, running 3. I can do that a couple times and still keep on the grid. My next one, I start here at the y-intercept of 2, going down 1 over 2 many times until I find the spot where it touches the other line. That intersection is the ordered pair x is 6 and y is down at -1. All right, our next example here, I have two equations this time that are in standard form. And if you remember standard form, we cover and divide. Cover up meaning I put a 0 in for x. When I put 0 in for x and I cover that term up, y ends up equaling -6. When I cover up the y or put 0 for it and solve for x, I would divide by 2. Dividing 2 would give me x. Dividing 2 here would give me -3. So the intercepts are -3, 0 for the x-intercept, and 0, -6 for the y. It has nothing to do with graphing the slope. All it is just 2 points. If I plot those 2 points at -3, 0, 0, -6, we draw that line. The second one, cover and divide, I get an x-intercept here of 3. The y-intercept is -3, because -y would equal 3 when I covered up that x. We'll put 0 in for it and divide by the -1 to get -3. So 0, -3, and 3, 0 are our points to plot. we plot those two ordered pairs, and I graph the line, and I see the intersection of these two lines right here, and that's over here on the x-axis, -1, down on the y-axis at -4. So our solution is the ordered pair -1, -4, the intersection of those two lines. And our next example, once again, these guys are both in standard form, cover and dividing. Well, if I cover up 3y or put 0 in there, divide by 2, the x value is -6. Cover up the x, divide by -3 to get the y value of 4. So the y-intercept is 4, the x-intercept is -6. Plot those 2 points. When I plot them and draw the line, that's what it's going to look like. The next one, I've got the intercept labeled here already as 3, 0, 0, -2. When I draw those two lines, there is no intersection. They're parallel. That would not be your answer, though. When you see that you have parallel lines, you would have to tell me that it is a no solution. So give me a no solution as your answer, and that one's looking good. Another way to know that they're parallel is we could look and say, well, the slope of this line, I rise 1, 2, 3, 4, I run over 6. So it's a rise 4 and run 6, which is 2/3 reduced. This I rise 2, I run 3. Its slope is also 2/3. If their slopes are equal, they are parallel. So that's another way to tell that they're parallels if they have the same slopes. Take a look at my next graph here. The y-intercept, when I cover up the x, put 0 in for 3x, y equals 6. So it's the ordered pair 0, 6. When I put in the 0 for y, I cover this up and divide by 3. My x value would be 2. Give me an x-intercept of 2, 0. So I plot that point here on the x-axis. 0, 6, I go up on the y-axis to a +6 and draw the line. My next line has a y-intercept of 6. So here we start right there at that same spot at 6. We rise -3 and we run over 1. As I rise 3 and run 1, I find out that this ends up being the exact same line. And in that case, there are an infinite number of solutions. At this point, you should pause the video, take a moment, graph these two systems of equations, come up with your solutions. And then after you've done that, go ahead and turn the video back on so you can see and check your work to find out if you've got them correct. All right, on the first example, you've got your y-intercept of -6. I'm rising 1, running 2, draw the line. My second equation, I start at 4. I rise 1, run 2, and yes, they are parallel to each other. And looking at this, I can see, yeah, the slopes are the same. If they're the same slopes, no, they're never going to run into each other. Continuing to rise 1 and run 2 at the same rate. So this is a no solution. All right, on your second solo problem, the first equation, you've got a y-intercept of -3. So I start down here at -3. We rise 2, run 3, draw the line. Your intercepts here, when you cover up the y, the x-intercept is 4. So that's how I got the ordered pair 4, 0. Cover up the x, and you've got -y equals 4, which would give me the ordered pair of 0, -4. Plot those 2 points very carefully and draw the line. If you're not sure, I can look at this and say, well, I rise 4 and run 4. So going up 1 over 1, up 1 over 1, and up 1 over 1 again hits exactly on that point where I plotted the purple line. So yes, the intersection here for this guy is the ordered pair of x is 3 and y is down at -1. Well, that's it for the systems of equations, solving by graphing. If you have any questions, you can see me online and we'll discuss. So anyway, we'll talk to you later.